We showed in an earlier lesson that at latitudes above the Arctic and Antarctic circles, it was possible to have continuous daylight or continuous darkness at certain times of the year. These symbols are used in the air almanac to indicate these phenomena. Let's look at what they mean. The first indicates that the sun remains continuously above the horizon. This occurs at a high latitude summer. The path of the sun is like this. It comes down and up in the usual way, but at its lowest point, which is at midnight, it is still above the horizon. There is no sunset or sunrise. The second symbol means that the sun remains continuously below the horizon. This occurs at a high latitude winter. The sun comes up and down in the usual way, but at its highest point, which is at midday, it is still below the horizon. There is no sunrise or sunset. And the final symbol means that in the period between sunset and sunrise, the sun is never less than 6 degrees below the sensible horizon. This occurs during a high latitude summer. The sun sets, but at its lowest point, at midnight, it has not reached 6 degrees below the horizon. We still get a sunset and sunrise, but twilight lasts all night. The sunrise, sunset and twilight tables are based on an observer at mean sea level on flat ground or looking out to sea. An increase in altitude will increase the sensible horizon, thus making sunset later and sunrise earlier. It also makes twilight shorter. However, you will not be required to calculate any of this. A further variable to the length of twilight is caused by volcanic activity. In an area of volcanic eruption, the length of twilight will be increased due to the increased scattering of the sun's rays. In practice, you are unlikely to be flying in such conditions. Finally, you should note that the beginning and end of civil twilight are the practical basis for working out when it gets too dark to see safely, and can be used worldwide. However, within the UK, the Air Navigation Order states that for legal purposes, such as logbook entries, night flying takes place 30 minutes after sunset until 30 minutes before sunrise. Let's summarize this lesson. We showed that the times of sunrise and sunset are determined by latitude and the sun's declination. At the defined time of sunrise or sunset, the sun is a total of 50 minutes below the sensible horizon. This is the figure that is used in the air almanac tables. It always makes at least 3 minutes difference at both ends of the day. We saw how to look up the times of sunrise in the air almanac. But these are local mean times. To make them useful to us, we have to convert to UTC, and then possibly to standard time if required. However, before sunrise and after sunset, there is a period when it is still light enough for everyday tasks, including landing and taking off from an airfield without lighting. This period is known as civil twilight. There are also periods of nautical twilight and astronomical twilight, but these need not concern us as aviators. The local mean times of the beginning of morning civil twilight and the end of evening civil twilight are given in the air almanac in the same format as the sunrise and sunset tables. Again, they need to be converted to UTC to be useful. To find the duration of twilight, compare its time with that of sunrise or sunset as appropriate. Twilight can never be shorter than 21 minutes, which occurs at the equator at an equinox. Remember the significance of the 3 symbols used in the air almanac to cover high latitude special cases. An increase in altitude will increase the sensible horizon, thus making sunset later and sunrise earlier. It also makes twilight shorter. Finally, within the UK, the Air Navigation Order states that for legal purposes, such as logbook entries, night flying takes place 30 minutes after sunset until 30 minutes before sunrise. This concludes all of the lessons on time.